So, hello, welcome to our group theory lecture 5 part 2. In this lecture, first I will give one example of a unit in a monoid which I have told you guys to think of in lecture 4. So, an example of a unit in a monoid is that we all know Zn is a monoid under the operation multiplication. So, and the set of Zn stands like this: 0, 1, 2 rod up to n minus 1 under multiplication mod n. In this set, in this group monoid, 1 is the identity element and obviously all units of this monoid will be, for all a belongs to Zn, such that GCD of a, the element in Zn, and n is equals to 1. Let me give an example of this scenario. So this will be like, for Z8 it will be, the units will be 1, 3, 5, 7, because for any element, if for any element a belong to Z8, if I take GCD of them with 1, 3, 5 or 7 with element a, the GCD will give 1. So these elements of the set Zn will become units of the monoid Z8 dot under operation binary operation multiplication. Next, I will discuss another problem which I should have discussed in lecture 5 part 1, and in this lecture, uh, let S not be a semi group with identity element E if each element in S be right invertible. Prove each element in S also left invertible. So let's put to the solution. So what I have given, for every, let A belongs to any element of the set and A dash is the right inverse of A. Since and since A is right invertible, there will exist a right inverse whatever, and since A dash also belongs to S, so there will exist another A double dash belongs to S, which is right inverse of A dash. Now since A dash is the right inverse of A, we can and let E be the identity element and not be the binary composition. So we can say A dash equals to E, since A dash is the right inverse. So A dash equals to E. Similarly, A double dash is the right inverse of A dash. We can say A dash compose right A double dash is equals to E. Now A dash compose A equals to what we can write it A dash compose A, clearly compose A not E, because we compose anything with the identity element will return another that element. It's property of the identity element. So we can write this like this, and again this is equals to, we can write E as a dash not a double dash. Say this is equation 2, this is equation 1. So from equation 2 we can write this as a dash not a dash compose a double dash. Now by associative property we can write this a dash compose a not a dash s, which will be equals to a dash compose. This is what? This is where from equation 1 we can write it as E compose a double dash equals to a dash compose. Now composition with any element with E by property of identity, this will become by simply property of identity. This can be written as a dash compose a double dash, which is equals to E. So what we can see, a dash for an arbitrary, we have taken an arbitrary element A belongs to S, and we are getting that there exists an element A dash such that because A dash belongs to S such that A dash compose A equals to identity. So the left inverse exists. So I end my lecture here and the problem is done. Left inverse exists basically. Thank you for watching. More in the next videos. Thank you.